what is artificial intelligence? Let's understand it. Humans are the most intelligent form of species that has ever existed on Earth. We excel in everything that we do, whether it is science or arts or sports. Human brain is the most intelligent thing on this earth. Now, this is real intelligence. When we intend to replicate this intelligence into a machine, meaning we are trying to make a machine as smart, as intelligent as a human being, that is called as artificial intelligence or AI. So, artificial intelligence is the development of machines that can perform tasks that typically require human intelligence. For example, you can create AI systems that can diagnose diseases from X ray, or they can predict property prices, or they can even detect credit card frauds. All of these are things that humans have done with their typical intelligence, but we can have machines do the same, and that's what artificial intelligence or AI is, incorporating human like intelligence into machines. Now, there is a question that can come into your mind is how would machines do that? How can they become as intelligent as human beings? And that is where the concept of machine learning comes in. So, what is machine learning? Obviously, as the name suggests, you are trying to make machines learn something, you are trying to teach them something, and the objective here is to train machines in such a way that they can make predictions, they can make decisions, all by learning on their own and without requiring any explicit programming from humans. We train a machine, it learns on things, and then able to perform predictions or whatever it is needed without human involvement. That is what machine learning is. Now, after reading this, there is another question that would come into your mind is okay, how can we do that? But how can we make machines learn? So think about it. And guys, I am going to go one step at a time. We will take one level at a time, and I'll tell you all of this in a very simple way, very interactive way, so that your concepts are absolutely clear. So if you think about it, right, how do we humans learn something? For example, there is a child, and how would he or she learn about, say, what is an apple? They will see lot of fruits around them. They will see banana, they will see orange, they will see apple, and over time they will understand that okay, anything that is round, anything that is red in color is an apple. And next time when this kid sees 10 fruits placed in front of him or her, they can easily identify which one is an apple because they have memorized some properties of the fruit. They have seen it, they have learned it, and that's the way we all learn things. We see examples of something, we memorize what it is, what are the unique attributes of that object, so that next time when something is shown to us, we can identify whether it is an apple or not. And that's the same way that machines also learn, except that they have to be trained on lots and lots of data. So we will show the machine learning model millions of images of apple, different shape, different size, different colors, different variants. And the idea is that now if you present an image of two fruits in front of the machine, it would be able to identify based on what it has learned from this training data, whether it is an apple or not, right? So the concept behind machine learning remains the same, like how we humans also learn, but there are a few specific things that are different. First of all, you need lot of training data. As I mentioned before also, humans are intelligent. We can recognize, let's say, a cat when we see it, whether the cat is golden in color or it is black or it is white, whether it is covered in mud, whether it's a small baby or a grown up, we can do all of that easily. But to make machines do the same thing, to incorporate the same level of intelligence into them, we need lots of training data. We have to show them millions of images of cat, different colors, different variants, different size to get that level of accuracy. Then we need significant computational power because we are talking about massive amount of data to process, lot of computations to be done, lot of optimizations to be done. We need powerful systems. In the past days, machine learning models were kind of limited because of the computational power that was available. But now with the low cost and availability of GPUs, computing power has increased tremendously, which is why you see that these latest models are so advanced. And finally, we need a solid algorithm behind the scene that will process all this information, that will learn from the training data, that will identify patterns, that will predict results, do all the execution work for you. So again, the idea is that you give machines tons of data, you let them analyze it, you let them identify patterns, attributes, clusters, and then you can expect that the machine is now intelligent and it can do all this work for you without requiring human intervention. That is how you make machines learn. That is how you develop their artificial intelligence. Okay, so now that we know what artificial intelligence is, what machine learning is, let's talk about one more variation of machine learning, which is deep learning. Now, as I said, deep learning is a form of machine learning only, but the logic behind it is based on the concept of neurons that we humans have. If you think about it, right, how does human body transmit information? Our body has these network of neurons which are tied to each other. And say, for example, when you see something from your eyes, these neurons transmit information from one to another, and eventually it reaches to your brain, which analyzes the object and tells you that, okay, what you are looking at is an apple or cat. So the key takeaway here is that these neurons are like multiple layers with each one connected to the other, and they are processing information, they are transmitting it to the next stage. And this whole idea of having multiple stages, multiple layers, each one processing information, enhancing it, sending it to the next one, is what really makes humans so intelligent. So the engineers thought that, okay, that is great. This is what makes human awesome. So how do we replicate it? What if we apply the same concept to machine learning? And that's where they created something called neural networks. And here also, as you can see, there are multiple computational layers. Each layer is taking the information from the previous layer, analyzing it, learning from it, enhancing it, and then passing it on to the next layer. This next layer again processes it, analyzes it, learns from it, and sends it to the next one, and so on. So the idea here is that when we have a neural network like this that has multiple layers doing the analysis for us, our accuracy on complex problems like text generation, for example, improves significantly, because we are now passing the training data through many layers, and each layer is analyzing that data, it is doing computations on it, it is learning from it, predicting things, and that improves the overall output. That helps you achieve much greater accuracy. And actually, guys, this neural network is the model that generative tools like ChatGPT are also using, and we will see it in more detail in the next modules. But really, the key takeaway here is that for complex problems like text generation or image generation, deep learning models like neural networks outperform other older machine learning models. And that is simply because of their multi-layered structure that you see over here. Another thing that you may have taken a guess by now is that this solution is very complex. It would require a lot of computational power to move the data, lot of computational power to analyze this data, process it, enhance it, predict it, whatever. And you are totally right. Neural networks do require a lot of computational power, and that was something that was limiting their adoption and improvement in the past. But like I said earlier also, with the recent advancements in computational power, GPU and whatnot, neural networks have become much cheaper to train, much cheaper to use, and that is driving their adoption, especially in areas of generative AI. So what is deep learning? Let's take a look at the definition now. It's a subset of machine learning, and it processes data through neural network, and this results in more accuracy for complicated problem. So no need to remember all of this, just remember the simple details, and just three things is really what you should take away from this slide. Is number one, deep learning is a subset of machine learning. Two, it uses neural network. And three, it gives you much higher accurate, better results in case of complex problem. So guys, this was about artificial intelligence, machine learning, and deep learning. Just to put them in a single view, in a single context, we have artificial intelligence that refers to creating machines that are intelligent as humans. that mean creating machines where you want them to typically have the same intelligence level that humans originally have. Two, we have machine learning, which we can say is an enabler for artificial intelligence. It allows machine to learn and improve over time. And finally, we have deep learning, which is a subset of machine learning, and it uses neural networks to solve on the complex problem. So these were the three key topics that we wanted to discuss before we move forward and take another look at generative AI in much detail. So with this sorted, let's go to the next video and let's take a more deep dive approach on generative AI. I'll see you in there. Thank you.